thank you for joining our latest episode of Golang Live, part of the live series events that we run over here at Amicus Recruitment. So for those who don't know, I've met a number of you before, but my name is Jake O'Regan. I am a Golang specialist recruiter, specializing in recruiting for Golang engineers of all levels to companies across Germany and also now remotely across Europe. I'm delighted once again to be joined by Anderson Queiroz, who's from Elastic, is a Golang specialist, and he's created tonight's webinar, which is titled Event Sourcing with Go. So it should last around 30 minutes this evening. So we want to keep it as interactive as possible as well. So if people do have questions, please ask throughout, but we will leave some time at the end for people to ask questions as well. So please use the Q&A option if you do have anything that needs urgently answering throughout. I'll interrupt Anderson with his permission once he's finished his sentences, and yeah, we'll see if we can answer the questions. But yeah, without further ado, I'll hand over to you, Anderson.
Thank you very much, Jake. So good evening, everyone. Let me share my screen. Okay, yeah. As Jake said, the idea today is to talk about event sourcing with Go, right? Currently, I'm software engineer at Elastic. What I'm going to share today is from my experience working with Go in event source, but on my past company that was Blacklane, that's a chauffeur company, right? I'm going to share a bit about, so okay, first, who am I, right? I'm a Brazilian. I'm living here in Berlin since 2018. I've been coding for about 15 years. I started quite young when I was an adolescent. I've been working with Go for more than 4 years already. And yeah, since I discovered Go, like I chose as my language, right? And nowadays I'm sure that I'm keeping working with that. So the agenda for today, first, I'm going to talk a bit about some concepts, right, to set the stage, and we all are in the same level about the concepts. I'm going to talk about some real life examples, things that we learn when using event sourcing and event-driven architecture at Blacklane. And then I'm going to show you a library that we implemented there to make it easier to work with event sourcing in Go, right? And I'm going to show you both as a user and a bit of the behind the scenes, right? The implementation. I'm going to show here a shorter version of the implementation. I'm not going to dive deep in the whole code, right? But it's an open source library. At the end, you're going to find, I'm going to have a slide with my GitHub and also the library's GitHub, so you can go and check everything out there, right? So let's start. So first thing, right? What's an event-driven architecture? The idea is basically an architecture, a pattern, where the different components of your architecture, the systems, they're going to communicate asynchronously, usually by publishing messages and events, using something as a message broker like Kafka, RabbitMQ, Amazon SNS, or something similar, right? And event sourcing, different from to say how you communicate, different systems communicate. Event source is how you store and you represent your data. In event sourcing, you have append-only store. So that means that every change that happens to an entity, instead of changing the whole thing, you create a new event that this event shows what changed in your entity. And how do you see the current state of your entity? You basically go through all the events and apply one after the other, and you get the current state, right? That's quite different from a relational database, where you only have the current state. Every time that you change something, your whole representation changes and you lose the past. You don't know what it was before, unless of course you implement something else to gather this history, but it's not the normal case, right? So these events, they should be immutable, right? So you are sure that you are consistent. You can always reconstruct the current state, right? And it brings something really interesting, right? Because using event sourcing, you can not only know how an entity changed through time, but you can replay how it happened, right? You can stop at some point in the past, right? Let's say I want to know how was my shopping cart, my order 2 days ago, right? You don't have to replay everything at once. You can stop and you can analyze all this data and this change. So, right? And then if you mix and match them two, you can use the idea of event sourcing and publish these events in an event-driven architecture. So different systems, they can watch and react to changes in an entity, but they don't have to be directly connected, right? So the system that owns the entity, it just publishes everything that happens, every event, every change, and whatever system might be interested on this change, it consumes the event and it reacts to it, right? And then we're talking about a lot of events, but exactly what is this event, right? We understand that there is a synchronous communication on that, and also it's like the piece and bits of my data, right? So quoting here, Greg Young, he says that event is something that has happened in the past, and all the events should be represented as verb in the past tense as customer relocated, cargo shipped, inventory losers recorded. For those who speak French, it should be in passé composé. Sorry, my French, no idea if I pronounced correctly. And there are things that have completed in the past, right? I really took care and I looked at the grammar. This is past simple in English. I have no idea why he chooses French over English, but the most important thing here, event is something that started and finished in a given point in time. It didn't take a long time in the past to happen, right? It's not happening. It didn't start in the past, it's happening now. It's completely completed, right? And you see how it represents on the verb, right? So given that, right, as I said, when I was at Blacklane at some point, we started to change our architecture from an event-driven architecture with event sourcing. And throughout this process and having a whole company moving to that at the same time, there were a lot of learnings, right? And now let's say a bit of do's and don'ts with events. So one thing that I think that's the first thing when you really start to adopt an asynchronous architecture, right? You start to want to make everything asynchronous, right? Depending how excited are the engineers about, they really want to make everything asynchronous, and synchronous stuff started to become almost a sin, right? And then you start to have things, events, right? And you have events and their verbs in the past. Full thing requested, full thing response, responded has to be in the past, right? This is not, we did have it for some time. This is not really an event, right? You're really just mimicking HTTP here and using events on it. The point here is that you are going to end up having a mix and match of both synchronous and asynchronous parts. Some things are going to be event source, event driven, and some things still being synchronous with HTTP. And then this is fine and it's necessary, right? It's not because you have a hammer, everything's a nail. Another thing that we learned at the beginning, as we started to publish the changes in your entity as events, and everyone can consume that, right? You have to be aware that depending on how you set up architecture, different services are going to be publishing different things. And you might end up in a situation like here. Imagine that you're requesting a ride, right? And you wanted to assign a chauffeur to this ride. And then the ride service creates the ride. Ride created is emitted. The ride matcher listens to this event, consumes that, and then emits a ride chauffeur assigned. Looks fine. But if you stop to thinking for a bit, you have two services that do different things, and they change the same entity. By publishing events about the same entity, they are ineffective, changing the same entity. What happens here, if you are thinking about a relational database, is having two services that both are changing the same role on the database, right? So this is something that is important to be careful and do not mix these boundaries, right? As a rule of thumb, you have one publisher for one entity, right? So just one service can publish events about this entity. And the other service, they can listen, and they have to listen and react to that. But they are going to publish other things about other entities, right? About other domains. And they're going to communicate with that, but do not have more than one service publishing events about the same entity, right? And here then the solution on this example, yes, we start having two different topics with two entities. One was right fulfillment, that we talk about finding chauffeurs, if it worked or not, and the rides itself, right, to be the entity that you can't assign a chauffeur or not. And this both services would cooperate, right? Some parts to event and some parts synchronous as well, right? Sorry, I have a strong allergy and this weather is not helping here in Berlin. So when you start to go to this sort of architecture, where is the data, right? If you're having my entities stored with event source as events and publishing that, indeed your data is going to be really everywhere. One advantage is it's super easy for any application to keep its own representation of the state as much as it needs, right? But at the same time, if you want to query it, either you keep a local copy or you have to read the topic in the storage every time you reapply the events. What most of the times it's fine, because most of the entities are not going to have a huge number of events, right? But you have distributed data, right? But this is exactly the same that we have with any microservice architecture. Your data is distributed across different data sources, right? There at Blacklane, what we end up doing was starting to create some sort of search service, right? Using Elasticsearch behind the scenes to be able to listen to these events and construct on Elasticsearch a representation of the current state and be able to search, right? And this was something that event source helped a lot, right? Because we didn't have to neither connect both data sources or have a explicit connection between this search service and all the different services, right? You could the search service would just listen to all the events regarding the entities that it cares about and just put it on Elasticsearch and update the indexes with that. And then with that, we have this plug and play ability, right? You can develop new features without necessarily change the service, right? So as an example here, let's say we have an order service. It takes care about online orders, right? You're buying something on a website, and now you wanted to send an email or an SMS, want to do something different when an order is created, right? If you're not using event source and event driven, probably what you do is go to the other service, and then you need either to notify or it would need to you need to change its code, right, in order to be able to know that the order was created. With events, that's easy. Just listen to the events created, the order created, and then you can react to that, right? So no change on the other services needed. And also, I guess you're all seeing a black thing on my screen, right? Sorry. Yeah, this is my piece of window that I see myself and Jake. Sorry about that. I think I can put something somewhere else. Oh, well, yeah, right. Okay, anyway, proceeding. Another ability that you get when you do event sourcing, as I said, you know the past, you know the changes that happen, how an entity got here. So imagine that you want to do a feature that you want to understand how much the address of an order is changed, right? Normally, if you're not using event-driven, you're using a normal relational database. You'd have to develop a feature, you would have to save this information every time that's changed somewhere, and then you would have to wait for a while to gather data and then be able to analyze. When you're using event sourcing, you have the past, right? You can go back and examine the events, analyze them, and gather intel. So it's super easy. Instead you have to stop and have to develop a whole new feature, you just run some script that goes to the events, gather the data, and analyzes that, right? So this is one of the great advantages. You're it's not only super easy to plug and play new features, but with the historical data, you can look at the past and ask questions that you didn't know that you would ask. As long as the data is there, it's super easy to query and analyze. Okay, that said, we understand a bit better what exactly I mean when I talk about events, what's an event, and how we handle them. The question now is how we do that in Go, right? Think about more on the perspective of the event-driven architecture, right? And publishing and consuming events. When you go out and start to look for the different libraries for different message brokers, what you get is something similar. What you see here is something too raw, right? You usually are giving either a method, a chain, or something that's going to deliver messages, and you have it in an infinite for loop. And most of the events, they end just printing it out, right? Just an output. That's a way behind what we need to be production ready, right? It's definitely too raw. Sorry. And you have to create all sorts of abstractions on top of it, right? One abstraction that we really know how to deal with is HTTP, right? I believe everyone here knows how to handle HTTP requests, understands a bit about middleware, how to do, it's easier to do distributed trace with HTTP, right? You understand, you have a request, that's an input, you're gonna process that in your handler, you're gonna produce some output, right? That's your response, but you might also save things on the database and so on. And on top of that, you have all the power of having middlewares, right? Things that are going to change, they're going to run either before or after your handler. You can use to track your performance, send data to our APM, some error tracking system like Raygun or something alike, where you can gather data and intel about what's happening in your handlers, right? And you don't have any of it for event. As we just saw, you have a for loop and deal with that. So as we were transitioning and do a company-wide change for that, it rose the need to, one, make it easier for everyone to adopt it quickly. Of course, in a company, you have different level of engineers, right, with different abilities and experiences, but also in a microservice environment, if every team in every service implements something completely different, it's super hard to maintain, to have people moving teams because there is too much specific knowledge, right? So the idea was really, let's create an HTTP-like abstraction, right? I got this idea, like, we know how to deal with HTTP. We know how to deal with requests, and you just have to handle events. It's the same thing. It's an input and an output, right? And if you want to wrap things around your handler, just let's do it. So the idea is really mimic HTTP. Let's look at what we do with an HTTP server. Let's look how we implement your handlers, and let's try to make something as close as possible. So we have an event type here. Most of the message brokers, they have headers as well. So that was super useful because the same kind of information that we send to HTTP headers, we started to send on event headers. We have a key, that's something event specific, right? And you have the payload, that's the same thing as the request body. And here, even the same thing, it's just a byte array. Sorry, a byte slice. The header is a map string to string. And you have the events handler interface, which the method is indeed handle, right? Not serve events, right? Receiving the context, the event, and returning the error. That's another thing I believe a lot of you either have wished or have created some HTTP handler that returns an error so you can wrap and have things handling the error. You in your handler just need to return the error. It doesn't have to care about how to notify your infrastructure and alerts and everything. Of course, some helper functions, the classical handle func. A lot of the times, what we're going to do with a handler is just write a function that handles. You don't need to implement all the methods on a type. The handler func does that for you. And the definition of a meter as a function that receives a handler and returns a handler, right? So now, how do you use it, right? From the user's perspective. Basically, what you do is to implement your handler. You have to write a function that receives an event and does something, right? So the implementation that we have is for Kafka. That's the message broker that we're using there, right? So you create a Kafka consumer. And the important part here is your handler. You register your handler pretty much the same way that you do with an HTTP server, right? And now the library is going to take care of all that for loop and everything. It's delegated to the library. You as a user, right, on developing the features in your system, you only have to deal with your handler. That's the only part that matters to you, right? Let someone else takes care of this burden. Also, once that you have created your consumer, you can start it, right? Calling the run method. On our implementation, the run is non-blocking, so it already runs asynchronously. You don't have to worry about it. You just have to take care to block your main coroutine so the program doesn't exit after calling run. And last but not least, graceful shutdown, right? It's super important that if you wanted to stop listening to events, you don't want to simply quit the application at once. You want to be able to say to your consumer, please stop, right? And give it some time so it stops receiving events. And all the handlers that are currently running, they have some time to finish working. Of course, with a context, so you can have some timeout, right? If the timeout's reached, then the consumer said, okay, I gave up, and these handlers that are running is not my problem anymore. I tried. And this is from the user's perspective, right? So now let's see a bit of what happens behind the scenes on the library. As I said, the code that I'm showing here is a simplification of what I did, but shows the main concepts, and later you can check the library's code as well. So the consumer is a really, really simple interface, right? That you can run or start the consume message, and you can shut down. That's it, right? Also, because everything else that's going to happen is really implementation specific, right? How do you do it for Kafka? How do you do for RabbitMQ? For Amazon SQS, that's going to be different. We have the implementation for Kafka, right? So inside the run function, as I said, a simplification of it. The first thing that we do is to launch a Go routine, right? So you have it running without blocking, and you have our infinite for loop with a flag that can stop it at any given point in time when you call shutdown. And then the Kafka specific part, we are using the pull method from Kafka, and you get a message, right? Every time that we get a message, we go through all our handlers, and the library let you register several handlers, and also there are helpers to add meters to the handlers.
Got a quick question here, Anderson, that's just come through from Nick. So thank you, Nick, for your question. The question is: should you kick off jobs in your event handler with Go routines, or just capture data?
No, your handler, it's gonna depend on what your handler is doing, right? You definitely, for some cases, you wanna launch all the Go routines and do other stuff, right? The point here is your handler is what receives the event, and how you deal with that is really a case by cases. What you need to do, if it takes long or not, right? You might want launch all the Go routines there to do other stuff. I hope I answered your question. Okay, but that's the thing, right? The library takes care of invoking all the handlers for you. You don't have to care about it. And then it launched the handler in a Go routine, right? So every new message is gonna run concurrently. And this is a critical part, right? They run concurrently. I don't know if you know Bill Kennedy, he's really known in the Go community. And he says concurrency is out of order execution. This is super important. Have it in your mind. Concurrency is out of order execution. The different message brokers, they're gonna have different guarantees. If you're using Kafka properly, you are guaranteed that you're gonna receive the message in the same sequence as they are published. However, it doesn't mean that your handlers are gonna run in the same sequence that the messages arrive, neither they're gonna finish in the same sequence, right? So you might have message 1 and 2, you're gonna receive in this order, you're gonna launch 2 Go routines, but it might run 2 and then 1, right? It might run 1 and then 2, and 2 finishes before 1, right? You don't have this guarantee in the order that the Go routines are gonna run. And of course, graceful shutdown, right? There's not much magic about it. Just we using here a wait group that when the follow-up quits, you wait on the other handlers to finish, right? So we consume the events and talk about a lot about consuming handle events, but you also need to produce. The producer part is actually the simplest. There's not much any trick thing to produce. You're basically gonna send some data to whatever message broker. So there's a producer interface. This one is the one that they grew the most because you didn't want to make any breaking change. But the producer is basically a send method, right? And a shutdown. Again, the shutdown is really important for graceful shutdown. Depending on the implementation that might have, the message broker, and then your configuration, even on Kafka, it might batch the message and not send everything at once. So before closing the application, you usually need to do some flushing in your producer to make sure that all the messages that are sent were indeed delivered, right? So this is the producer interface. And the implementation of the send, I'm not showing here the implementation because it's like completely Kafka calling the produce method on Kafka, right? There's nothing interesting about it. And the shutdown is flush. So that's the main set of abstractions that we created to work with events in Go, right? And it works, right? It was like at first, it's a rather simple implementation. It's borrowing all the concepts and the expertise that you have for abstractions with HTTP, right? With the meters, it allows us to easily integrate APM, distributed trace, and so on, right? Together with this event library, We also have a OpenTelemetry library that implements middlers that instrument the event handlers with OpenTelemetry as well. So if you're using that, you can either use it or have a reference implementation. This, of course, there is a bit of Blacklane specific stuff there, but it's something, right? But it also is a pretty much generic. There's nothing super specific, right? And also having it as a library, it allowed us to move fast and roll out changes easily across all the teams, right? And lastly, some choices that we made in the library. The event type is completely generic. That is something that I personally choose to do. One, because when we create the library, we were at the very beginning. So there was not a consensus yet in the company what would be like a default event schema, right? And as an open source library, it's really good that we didn't define anything there, right? Great candidate to put generics. I'm planning to play a bit with that soon as Go 1.18 is going to be released. As I said, you might need, depending on your use case, to ensure that some messages, they are processed in order. Usually the events that they refer to the same entity, right? This was one of the, I wouldn't say an issues from a bug perspective, but we first released the library and started using, and then we added this feature, right? But then it's there now. So given a message, an event key, there is a functionality you can choose that every single event with the same key, they are going to be processed in order, right? Because as I said, the two things, right? You might be unlucky and then the Go routine, you receive two events about the same entity super quickly, almost in the same instant, and they might run in the wrong order because of the Go scheduler, or it might just be that one starts and the other starts, but the other couldn't start until the first finishes, right? And pretty much we abstracted out Kafka away. Kafka is the only implementation that we have, right? It should be easy and doable to add and to use the same interfaces to implement other message brokers, but it's not 100% away. But you don't, the point is on the interface, there is no Kafka code, right? There is just one other concept there. If you're looking at the interface, you might realize that, right? So here on the slides, there are references about mean for the first part. When I talk about concepts, if you want to read more about it. And now, questions.
Okay, thank you very much, Anderson. There was a couple of questions that came through. I just want to confirm that this whole webinar has been recorded. So everybody will receive a link tomorrow. It'll be a YouTube link. So if there's anything that you missed and you wanted to go back and watch, yeah, everybody will receive a link for the YouTube replay of the webinar. There's a couple of questions that just come through. First of all, from Louis. How does this handle a large number of incoming events? Will this process them in batches or try to process everything at once?
It tries to process everything at once. So for even new event, it's going to launch a new Go routine. And that is it. There is neither rate limiting. You can do that in your Kafka configurations, right? But the current implementation doesn't set a maximum number of Go routines that might run concurrently, right?
Great stuff.
As it's Go, it can run definitely thousands at the same time with no much problem. So unless you're really under a really, really high load, it should work out of the box. So far, it didn't give us any problem at Blacklane.
Good stuff. Thank you. Another question that's come through is, how do you handle duplicates
Of the event? So the way that we configured Kafka was to do not receive duplicates. So we are not, okay, two things. One, as a library, right? That's our GoLib event. It doesn't care about it, right? It's the library delegates to the handler the responsibility of that, right? So the library is just trying to abstract the message broker infrastructure, and you have to take care of it, right? We didn't have any problem with that because either the things will be the potent or one that really we could afford, either double processing or even having a small mismatch on the sequence. It was like for chauffeur position, right? So you're always receiving positions, so it doesn't really matter if you lose one or two, or perhaps if you process the same position twice, you know. The only thing that we have to, but it's true for every single message broker, usually on a startup, if your application is down for some time or something, you might have received so many events at once that if it is not correct configured, your limits and memory and everything, then you might crash.
Okay. There's one that's just come through as well from Andre. So thank you, Andre. Is there a way to implement a worker pattern to cap the max number of Go routines that can handle events concurrently?
Yeah, definitely, right? I saw you change on the run method. You'd have some limitation here. I myself, I would try to limit the number of concurrent Go routines without making a pool of Go routines. I mean, having parked Go routines and just getting, once they are free, sending new work for that, right? It's so cheap to launch Go routines. It's better every time you have a cap limit. Okay, you know that you can run, I don't know, 10 at the same time, but just destroy them and recreate only if you really need, because the overhead is so small. The code that you're gonna need to write is more complex than just killing the Go routine and get a new one. Then if you one day have a performance problem, and then you know you have to really have some sort of Go routine pool, and then you implement that. But I would avoid the pool itself as a first option.
Great. Another one here. Do you use multi-threads? And if so, what's the best way of thread communication, in brackets, not concurrency?
I'm a bit puzzled. Okay, so first I have to ask a question. What do you mean by threads, right? In Go, you don't deal with threads. You don't really have a thread abstraction. You have Go routines. They're not exactly a thread. It's like a lightweight thread, right? And in Go, the easiest way is to use channels, right? To share memory by communicating, not communicating by sharing memory, right? And of course, you have mutex and the other things. Sorry, I think I didn't quite get your question.
No problem at all. And there's one from Queiroz here, final one of the evening. Have you considered using other libraries from Golang ecosystem? There's Watermill, for example, Watermill library, which does almost the same that you've just presented and has various backends implemented already. If you did consider this, how come you decided not to go with it?
No, we didn't consider this one when we were doing that. We looked at different, as I said, like a bit of history, like we did a change quite suddenly because of the pandemic, right? We started to build a new product. Different teams, they started to look at different possibilities. And most of the time we were looking about the libraries to connect with Kafka, right? And starting from that, that's how we decided to go with creating our own library. When I researched, I didn't find anything that was interesting, but I didn't find this one.
Okay. Well, finally, guys, from me, I just want to say a huge thank you to Anderson for tonight. You know, another great episode, and we actually sold out the event tonight for Golang Live. So thank you so much for everybody who's attended. I hope it was helpful to you guys. And like I say, a recording will be sent to everybody and will be on everyone's LinkedIn, etc. tomorrow. And yeah, keep an eye peeled for the next one. We'd love to have Anderson back and doing doing the third one for us. So yeah, thanks a lot, guys, for joining, and thank you so much, Anderson, for this evening.
Thank you very much. Have a nice evening.
Have a nice evening, guys. Thank you.
Bye-bye.
Take care.